Alright, hey and welcome to example 7. In this one we're going to take a look at how to do this. So it's a more controlled way of fracturing and removing constraints. So let's take a look at how to do that with some things inside of .NET. But yeah, let's start with geometry. Basically I'm going to start with just doing a normal Warner fracture. Nothing fancy, no clustering this time. I'm gonna move it up to a horizontal like this. I'm gonna create the constraint networks like this. Add the attributes that we need: constraint name glue, constraint type all. Let's just check so all the attributes are there. Yes, they seem to be there, and these seem to be there. All attributes are fine and great. So let's pack these with the assemble sub, create packed geometry, which will retain the name attribute. So these are the same name attribute now. Let's create a group on the side like this with these two geometries. I'm going to create a group of only the side here and here by first connecting this input to the first input of a group top and this input to the second input to the group top. In the group top, we're going to go to binding, we're going to go enable, and we're going to go to binding object, points only, and go to points, and we're going to put the group name to inactive. So basically what I want to do is I want to create an attribute on these points called active. I actually want to create an attribute to all of these called active, because active is an attribute that the RBD packed object will take in, and if an object has the active attribute set to 0, it will not be part of simulation. If it has an attribute called active set to 1, it will be part of the simulation. So it's basically a on and off switch if for any pieces you want to be simulated or not simulated. So I want all the pieces in these groups or in this group that has been grouped by these objects to be inactive, or more or less active set to 0. How can we do this? Well, I like to do it in an attribute wrangle. So in attribute wrangle, we're gonna first initialize an attribute called active, which is an integer, and we're gonna put it to active equals 1. So we're gonna write this, which means that all attributes, I'm just gonna comment this out. And comment this out. So that means that all attributes that comes in that is active is 1 for all the points. Alright. What I then want to do is I want to set every point that is in the group inactive to 0. And how I can do this is with an if statement. So if I type if parentheses f at group underscore inactive, that's how you access group attributes, by typing at group underscore the group name is not equal to 0, which means that a group attribute is also a boolean. It can be 0 and 1. We can check this by going in here to the group here. We can access group attributes, and this group and inactive is here. So if the group is 0, the piece is not in the group. If the group is 1, the group is in the piece is in the group. Basically, we want to set that if a piece has the group attribute set to 1, it's going to get the active attribute set to 0, which means that any point that's in the group is going to be inactive or have active equals to 0. This means that if you write if in parentheses f at group inactive is not equal to 0, which means that it's going to access only the pieces that have a group attribute set to 1, then we're going to set the active attributes to 0. And this is going to look like this. So the active attribute is now 1 for most of the pieces and 0 for a couple. How to visualize this? We can do an add, remove all the primitives, and just get the points, and then we can color them based on the attribute active. which means that if the attribute is 0, they are red, which is here and here. If the attribute is 1, they're green, which is in the middle, which means that all the red points are going to be inactive and all the green points are going to be active. Yeah, so that's it. So here we're just going to put a null to output the geometry, and here we're going to put a null to output the constraint network. Next up, we kind of want to direct this destruction a little bit. So how are we going to do that? Well, we are going to use just some simple spheres, and we're going to animate them by this fashion. So here's the brick, or like the road, or whatever we want to break. And here are two spheres I've animated just to cross over the surface. One a little bit smaller and one before the other, like this. And as you can see, they are actually going in the center of this, just on a straight path here. You can obviously animate it however you want, or you can animate it in the corners or zigzagging over or whatever. And then we're actually going to use these spheres to delete constraints from the constraint network, which means that the pieces, when a constraint is deleted, they will start to fall down and crumble. Let's have a look at how to do that. So we have all the components we need. We have the pieces here, we have the constraints here, and we have our constraint deleting objects here. So let's dive into the .NET and have a look at how this can work. So first of all, I'm just going to go over the normal things. We have our pieces here imported with an RPD packed object. We have our solver. As usual, nothing will happen when I scrub because we don't have any things going on them. It's a bit slow, regardless. Then we have the constraint network. In the constraint network, we have the glue constraint. We have the data name set to glue, the strength set to 2000. And we can visualize them by switching this off, going to this, and we can see that they're here. Perfect. So everything is working fine. We have the constraints, we have everything working normal. Let's see if we go to gravity and we play this. What is going to happen? Let's go. Nothing. And that's because of our inactive attribute. If we go ahead and switch that off, everything is just going to start falling down like that. What this inactive does, it keeps the edges here inactive, which means that the whole thing is going to be held up by them. And since the constraints are strong enough to keep it up, nothing is going to start falling down. What I'm going to do now is I'm going to break these constraints manually. So let's go here. Let's disable the geometry. So you just see the constraints, and let's add a new node called a subsolver. The subsolver is another solver, so you're gonna have to dive into it and do some things in there. But this one you can connect to the third input of the constraint network, and we're basically gonna be able to remove points from the glue constraints network with the spheres inside of the subsolver. Let's have a look at this. So let's dive into the subsolver. Inside the subsolver, we are gonna have 4 different nodes starting off with. Is a DOP geometry, which is just the geometry. If we go ahead and enable this, it should import regardless. Okay. Anyway, you have to input. Whatever comes in here is going to come in as the DOP geometry. But regardless, impacts is something else. Feedbacks is something else. What we are interested in is the relationship geometry. As you can see here, it actually brings in our constraint network by default, which is great. It kind of picks it up and brings it in. It picks up that we have a relationship constraint network somewhere in our .NET, and it brings it in. That's great. That's what we need. So we're gonna drag it down here, and we're gonna use it. So let's color this relationship geometry or the constraint primitives the color of black. They're still here. We can switch on the points, and we can see that there's still primitives going vaguely between these points. But I want it to be black for a specific reason, and that is because we are gonna bring in our animated spheres with this object merge here, which means that they will be animated like this inside our subsolver. We're gonna scatter some points inside of these, just like that. with the points from volume. We're gonna color these points red, 1, 0, 0. And then we're gonna use an attribute transfer. And what it's gonna look like is just when they pass, they're gonna start scattering their color on top of these constraints. And once that happens, let's pick a good moment like this. We're gonna add a delete sub afterwards. We're gonna put an expression. We're gonna delete by expression. We're gonna put the expression $CR is greater than 0.1. That means like if the color red, the CR color, is greater than 0.1, the point will be deleted. It's very important to put entity to point as well. But yeah. So if the color is greater than 0.1, the point is going to be removed. Like this. And we can see how they travel over and the primitives currently are being removed like that. So that's great. That's what we want. So let's see what that looks like in here. If we go here and we play this. Nothing happens. Interesting. Maybe we have to resimulate. Yeah, there we go. So now it starts deleting these primitives. And the second sphere comes and it deletes even more because it's a little bit bigger. Cool. So that means that these primitives or these constraints are being deleted. And that means our points can start to fall down. So let's enable the geometry again. And let's see how that looks. We're gonna have to resimulate that, I think. Let's go down to, we need to add gravity, that's why, absolutely. So once we go here, we're gonna have a ground plane here. We're gonna press this to just like hide it. We're gonna merge that in. The gravity, we're gonna put our display flag on the gravity, and let's see what that looks like. When a sphere comes, and pieces start to fall down. Yes, that's the way, and more pieces start to fall down because of the second sphere. And it seems to be working great. So that's perfect. That's what we want. So if you visualize this or like have it like that, we can see the sphere comes and the second sphere comes. So that's kind of how we can art direct these things. We can break constraints manually or a little bit more easier, a little bit more controlled. And yeah, I think that's it for this tutorial. I hope you learned something, and I'll see you guys in the next one. Thank you.